Okay, so when we look at the shape of alkanes, I've made a model here, and the model does not project real well, but I'm going to put it down here so you can sort of see. That's about as big as I can make it. See if I can zoom out any. Okay, so here's my model. I can have it all flat on the table, so all the hydrogens hit on the table. But more often we have two forms that we can do. The one is a boat. It takes these two end ones and goes up. So if I'm looking at it sideways, let's see if I can get it sideways for you right there, it makes a boat. Okay? The other way is if I take one of these, instead of putting both of them up, put one of them down. Then we get what is known as a chair. So it sort of looks like a chair from the side. So I'm going to hold it up so you can sort of see it. This is a chair. Okay? It doesn't project real great. And then if I take this and move it up, I get a boat conformation. Okay? You need to know the difference. Okay? Pretty easy. A chair you can sit in. So here's where you would sit in the back and the footrest if you got a kick for a footrest. Okay, so that's all that this part right here was. I know this is really awful. I should see if it'll focus again if I bring it in and out. There we go. Okay, so you need to know these are two different ways to show it. Okay, you need to know the boat conformation and the chair conformation. All right, let's go ahead and go to the next page. When we're looking, I'm going to bring it in just a little bit more. Hopefully it'll come in a little bit better, not too great. When we're looking here, what we're looking at are the carbon or methyl groups that are attached. Okay? So on this carbon one, if you look at where it's going, they're both on top. Okay? So I'm going to take two of these off, and I'm going to show you with it on top. So this would be like what they're seeing with them both on top. Okay? Now, this will bend and twist, but there's no way that I can twist this one down to the bottom. It just comes a little bit above the straight thing going across. In order to flip this, this is what's called the cis position, and the way I remember it is cis like as in sisters. They're the same, from the same family. In order to change this, I actually have to pull them off and put them back on in the position that I want them. This is trans. I think transcontinental from one side to the other side. However, it makes it easy for you to remember. So this one would be cis, and this one would be trans. Okay, and for those that are watching, this is sort of what it looks like, maybe. Okay, where it has one up and one down is trans. If I had two oranges up, it would be cis. And I just gave you that to sort of look at. Come back to this, hopefully. Seems to focus better if I come in and out. All right, so the next one, these are not real great. I'm going to draw over them so you can see them with mine. You can probably see enough of yours that you can do it. Okay, we are needing to also name, just like we've been naming, but we need to add cis or trans. So let's name this one like we have been naming it. What would it be? Wait, don't do cis or trans. Just do the basics like we did before. Start at the end. Start at the end. What is this? Cyclopropane. I heard pentane, but propane is 3. Okay, cyclopropane. Then what do? We identify what's coming off of it, right? Here is a methyl group, and here is a methyl group, right? How am I going to number it? Does it matter? It doesn't really matter. I could start here 1, 2, 3, or start here 1, 2, 3. Do I want to start here 1, 2, 3? Why? Because I want the lowest numbers. Okay, so we would put what? 1, 2 dash what? Dimethyl, good. And then it would go into cyclopropane, right? Now, these are both on the same side, so you guys were trying to give that to me at the first. That cis goes in front. Since it's letters, then we put a hyphen between it. Okay? So let's look at this next one. What do you think it's going to be named? It has the CH3 up here and the CH3 down here with hydrogen coming up and hydrogen going down. Basically, it's named the exact same thing except we put trans in the front. So we're going to go trans, 1,2, dimethyl, cyclopropane. Now, these next two get a little messy because they've shown us all the hydrogens. So the easiest way to do this is just to identify where's my groups and sort of make sure that we know where the groups are coming off. So I've got a group coming off here and a group coming off here, right? And I use blue because I use blue for methyl groups. Okay, so first of all, what is this circle ring called? Cyclohexane. Good. It has 6 things in it, and it's in a circle, so it's going to be cyclohexane. Back up. Now, what's coming off of it? 2 methyl groups. Where am I going to start counting? Wherever they are. I'm not going to start here and go around and get the other one, right? I'm going to go towards the other one. So I can start here or here. I'm just going to start here. 1, 2, 3, 4, 5, 6. Okay, so what is this named? Cis, good, because it's the same side. 1, 2, dimethyl. Would you do number 4? See if you can do number 4. I'm just going to circle a couple things for you. Okay, other than Jonathan, who thinks they've got the right answer? Okay, what's the right answer?
Oh, wait. Trans, 1, 2,
Good. So the only difference here is this one is trans. 1, 2, dimethyl, cyclohexane. Okay, so now we're going to go to number 5, but I'm going to do the harder one and leave you the easier one. So I'm going to come down to B. B has a few things coming off of it. Let's go ahead and just name it like we would. So it has 2 ethyl groups coming off right here. That bend right there, that's a carbon. And we have 2 bromine groups coming off right here. Okay, so tell me how to name it. Where am I going to start numbering? The top will give me lower numbers, right? Even though this is a B and this is an E, I'm still going to start at the top. So 1, 2, 3, 4, 5, 6. Okay. Bella, what is the last part? The very last part of the name? Good. So cyclohexane. Okay, let's see. Cameron, what is the very first of this? Very first. What would I use first? It's a good question. Ask one of your neighbors if they know what the answer is. Okay, go to the other side. See if the other side knows. Okay, so we need to go back and we need to think about this. Bromine starts with B, right? And ethane starts with E. We always start alphabetically. So who can help Cameron now? Can you help her? No? Bella? 3, 4 is right. Dibromo. You remember it's sort of redundant. We need to say where they're at and how many we have. Okay. Dan, who thinks they know what comes next? 1, 1. I'm still needing something in here. Yeah, I haven't dealt with my ethyls, so I need to say, how many ethyls are there? 2, and they're at 1, 1. So dimethyl. Now, if we read the instructions up here, it wants to show all the geometric isomers. So I just named it right here. Now I need to show it. So with me, draw. Okay? Since it's a hexagon, we're going to do the hexagon like we had up here. So we're going to draw it down here, sideways, because sideways we can easily show what's going on. I'm going to put my ethyl groups off this side because they're sort of obnoxious and hard to get off. And all I'm going to do is do it like a little pinchers. That still shows me there's 2 carbons coming off, right? And then at 3 and 4, so 1, 2, 3, there's a bromine. And at 4, there's a bromine. I put them on the same side, right? So these 2 are on the same side, so this would be what? Cis. And then I would go through and name just like we did before. Whoops, that shouldn't be a comma, that should be a hyphen. Dibromo dash 1, comma 1, dimethyl, diethyl. Oh, you guys, I screwed up there. Thank you for catching that. Diethyl. It should be on diethyl on both of them. Cyclohexane. So now we've got to show, I want you to try and draw by yourself right here, trans. Do a trans. And then go ahead and name it. I'm going to freeze it for a second. I'm going to draw it and see how well you do. Okay, another 30 seconds. We'll come back together. Okay, yes?
Why don't you put the cis or trans in the ethyls?
Because it goes at the very first. There's only one thing can, oh good, on the ethyls, because, let's see if I can do this real quick. So it's a 1, 2, 3. Whoops, forgot to take those off with it. So this is that monster right there. Okay? So because these ethyls are both coming from the same carbon, the question was, why can't they be called di or trans or cis on this one? The reason why is they're off the same carbon. So they can't be trans and cis. They've got to be off different carbons. Okay, so there's the, oh, it doesn't show. Okay, so how'd you do? Thumbs up, I got it. Thumbs down, I have no clue what I'm doing still. I need thumbs. I need to know where you're at. Have no idea. Okay. All right. Okay, yes. No, this bromine could be down and this bromine could be up as long as they're opposite. Okay? All right, so let's talk about some physical properties down at the bottom here. We need to know basic physical properties of alkanes. A homologous series just means a normal chain. That just means, remember I use the quotation straight. Okay? So, describe the key properties. A homogeneous chain is just basically a normal chain. Goes straight. As the carbon's number increases, the boiling point goes up and the melting point goes up, which makes sense. If you have one person, it's easy to get them motivated. If you have 2 people, a little bit harder. As you have 10 people, it's even harder. If you have 20 people, it's even harder to get them all on the same path going the same direction. Okay, hydrophobic. Who knows what that means? Water fearing. It hates water. In other words, it repels it. So if you put water and oil in the same, in the same container, oil will float on top. Okay, so, and I just answered that one. At what length carbon chains at room temperature become a liquid? So let's think about this. You guys know some carbon chains. Methane is what we use in lab. Is it a liquid, gas, or a solid? It's a gas. Okay, propane's what you use on your barbecue grills. Is it liquid, gas, or solid? Gas. Okay, octane is what you put in your cars. Liquid, solid, or gas? Liquid. When you go backpacking, you usually use a butane cylinder full of stuff for your cooking. What is that? It's a gas. Once I get to pentane, it turns to a liquid. So, C1 through C4 are gases at room temperature. C5 through C20 are liquids, and above C20 are solids.
How's your name, C20?
We won't have to worry about that right now. Dodeca octane. Okay, so you just have to worry up through 10. So this is just intro. All right. We okay to go forward? I love when they come and evaluate me when I can't talk very great and have to sit and do this boring stuff. Okay, we're going forward? All right, so this next one, it says to predict the boiling point of N-hexane. So what did we just learn?
Iron, C1 through C4 is liquid.
It's liquid at room temperature. Okay, so what is the boiling point? Good. Okay, is it soluble in water? Is it soluble in water? Do oil and water mix? No. Okay, is it soluble in ethane? Why do you say yes? That's true. It is not, they're both nonpolar. It's not that they're both a liquid, but that they're both nonpolar. So yes, it will be soluble in ethane. So basically, they usually use the phrase like dissolves like. Do not choose that on the test. You need to be more specific. In other words, they have the same properties, therefore they'll dissolve in each other. Or they don't have the same properties, therefore they won't dissolve in each other. Meaning polar and nonpolar. Or the molecule is polar, the other molecule is polar, therefore they'll dissolve in each other. Or nonpolar and polar won't dissolve. So be a little bit more specific, okay? More or less dense than water? Less. Okay, so now we go back to writing combustion equations. Anybody tell me what a combustion equation is?
Reactants equal the CO2 plus H2O.
Okay, so we get CO2 plus H2O. Always. What else is always in the reactants? Sorry, this is really sucky. Doesn't want to come in at all, does it? There we go, a little better. Oxygen, O2. Okay, and I can put any compound here, right? Any carbon compound, H, X, Y. It could have oxygen, it could have sulfur, but it has to have these two because we've got these two in the products. Okay, so we also need to know if they'll react with these things. Strong acids, what do you think? If I'm adding H plus to alkanes, is it going to do anything? So an alkane is basically like this, right, with hydrogens all around it. If I add an H plus to it, is there going to be a reaction? No, there's no more room. So there's no reaction. What if instead of the H plus, I add an OH minus? It's also no reaction. It's not strong enough to pull it away from the alkane. Okay? And it is not alkanes. So alkanes will not react with most, I should put reacts, with most reducing or oxidizing agents. They will not. Okay, paraffin. When we talk about paraffin, paraffin is a very long chain, usually C42H. Double of that plus 2 is 86. So let's write the equation for the combustion of paraffin. I need to balance it. Take a second, see what you can do to balance it. Oh, I didn't freeze it on the screen. Sorry. There we go. Guys need to tell me when I run out of the room on the page. I need a Coke. Gets a little hairy with this one. Let's see how you did. So 2 times 84 plus 86 is 137. Nope, it's not. I screwed up. I didn't add right.
85, because the 42 plus 43 is 85. So 85 oxygens, then to this better than by 2, right?
No, it still can't be 85. So 84, 84, and 86. So 14, carry the 1, 17. I got 154. That's still not right. I cannot add, guys. I can 254, thank you. I was going 84 and 84 and 84 is not 156. Okay, so it takes a little bit of adding. I didn't have a calculator. I guess I did. I forgot those in the sink. Okay? As the carbon gets higher, it gets more tough to balance. Okay? But take time and do it. Chemical properties, the combustion. If you have an incomplete combustion, you're going to end up with CO or carbon plus water. Notice water always gets the oxygen. If it's just a regular combustion, then I'm going to just have CO2 and water. But if I don't have enough, first it will go to carbon monoxide and water. If I really don't have enough, it will go to carbon and water. Okay? So, down here, we want to be able to balance these equations. So let's go ahead, and butane is just 1, 2, 3, 4, and it would be C4, H, 8 plus 2 is 10. Isopentane, so we have 1, 2, 3, 4, 5 with 1 coming off, because iso means the same on both sides. So we would have 1, 2, 3, 4, 5, 6, H, 12 plus 2 is 14. Cyclopropane, we've got this with a methyl coming off. So we have 4 carbons. This one gets a little tricky, so I'm going to use my marker here. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 hydrogens. I want you to go ahead and set this up as a combustion reaction and go ahead and balance it. I'm going to freeze this and I'm going to do it while you're trying. Okay, when you finish, go ahead and look up. How do we do? Thumbs up, thumbs down, thumbs sideways. Okay. All right, so we need to be able to balance a combustion reaction. That's very important for organic chemistry. Now, here's my caution. When you do your test, use lots of scratch paper. Bring it down from the screen. Make sure you got it down right on a piece of paper. Go ahead and name it then, and then look at the answers. Okay? That's my big, big concern with it. Because if you just look at the answers, you'll go, oh yeah, it could be named that way, and there might be a number off, or they forgot the dye, or, you know. So if you've got it written down as you should have named it, it'll be very easy. Now, on the next thing, the next page is review for the test. This does not have answers. I would like you to have this page and the next page done for next time. We'll go over the answers, and then the next time we'll go over whatever's left, kind of thing, until we get to the end. So we'll have something that we do every day to go over. But I want you to try on your own to get the answers. And then if you don't have them right when we go over them next time, write down how to do them right. Okay, the other key is, as you're looking at your book, if we go up here to the very front of the chapter, there are some learning objectives. This is where she makes sure there's at least one question on each learning objective. Okay, so you might want to look over that. It gives you the sections where they're taught. If you don't know what it's talking about, go to that section. Okay? All right, we are going to have time of your own to work on sapling, to work on your labs, to work on whatever you need to. Okay? Use the time wisely.